Hello, Assalamualaikum warahmatullahi wabarakatuh, and good morning, everyone. So, welcome back to UITM and welcome to week 7. So, give me a second. Okay, all right. So, this is the scheme of work again, and we are now in week 7. Okay, we are now here. Okay, so starting from this week, we are going to discuss on topic 3, that is on the hypothesis testing. And the first subtopic in this chapter is to discuss about the one population mean. Actually, we have discussed this in chapter 2, that is on the confidence interval, in which in chapter 2, I hope you still remember, we have discussed on how to calculate the confidence interval when it comes to one population mean and two population means, in which we're going to also discuss the testing of hypothesis of two population means. Okay, in chapter 2, we have discussed on how to calculate the confidence interval of the two population means. And the last, sorry, next is in week 8, we are going to discuss two. Um, the other one is to test the hypothesis of two population means when the two populations or sorry or the when the variables are dependent as well as when the variables are independent. Okay, and then in week 8 is the submission of assignment, that is assessment 2. Okay, I think I have shared with you the assignment during your semester break. So the submission of the assignment will be on week 8. And then in week 7, we are going to discuss on how to calculate the test the hypothesis when it comes to one population variance as well as the two population variances. And if you notice, all of these subtopic have been discussed actually in chapter 2. It is just that in chapter 2, we just discuss on how to calculate the confidence interval. Okay, and in this chapter we are going to discuss on the hypothesis by using the um, statistical test, right? By using the T calculator or the Z calculator, depends on whether the variance of the population is known or unknown. So we call this one as the statistical test. Okay, statistical test. And for your information, in the hypothesis testing, we can actually use three methods. The first one is by using confidence interval. We can also test the hypothesis by using this method, and we can use the statistical test. And the last one is we can also use the p-value here. If you notice here, we have one subtopic that is by using the p-value to test the hypothesis. All right. So in this chapter, we are going to discuss these two uh, techniques on testing the hypothesis. All right. And again, I have mentioned this in our previous classes. If you are good enough, you are able to understand what have been discussed in chapter 2, that is on confidence interval, especially when it comes to the selection of the formula, deciding on whether to use the Z distribution or the T distribution. If you have no problems in identifying the scenario to solve the problem, whether to use one population mean or whether to use the two population means when the variables are independent or independent, etc., etc. then you won't have problems in understanding chapter 3 as well. All right. So I hope you have you did your revision during your semester break so that you are better prepared to learn new things in chapter 3. Okay, now let's move to the chapter 3. Okay, so chapter 3 here. Okay, this is chapter 3 that is on the hypothesis testing. I okay. All right. So let's look at the introduction. A person who has indicted for committing a crime and is being tried in the court. Based on the available evidence, the judge or jury will make one of the two possible decisions. Okay, so whenever a person who has indicted for committing a crime in the court, there there are only two possible decisions to that person. It is either the person is found guilty, sorry, found not guilty, or the person is found guilty. Okay, and at the outset of the trial, the person is presumed to be not guilty. Okay, we presume the person to be not guilty until it is proven based on the evidence, until it is proven that they has committed the crime. If there are enough evidence to prove that the person has committed the crime, only then we will um, I mean we will judge, okay, that the person is guilty. All right, the same goes to the hypothesis testing. We have two hypotheses. The null hypothesis here is the person is not guilty, and the alternative hypothesis is the person is guilty. So we have two hypotheses. So this is actually the first step in the hypothesis testing, in which you have to write down the hypothesis, the null hypothesis, and the alternative hypothesis. And for the null hypothesis, okay, it is usually the hypothesis that is assumed to be true to begin with. Okay, so we started with that. With in our case right now, we start by thinking or by having an assumption that the person is not guilty. That is the hypothesis. Okay, and the null hypothesis is a statement that gives claim or statement about the population parameter. All right. Now, about the definition, statistical hypothesis is a conjecture of a population parameter. This conjecture may or may not be true. Okay, so we are going to test, or we are going to decide whether the conjecture is true or not based on the evidence or based on the data that we have. All right, and a null hypothesis is a claim about the population parameter that is assumed to be true until it is declared false. So now, let's say we have a null hypothesis earlier, and the hypothesis is the person is not guilty. Okay, so this is our first assumption. Okay, this is our assumption, and until we uh, until we have enough data or evidence to show that this assumption is not correct, okay, or not true, then we assume that it is true. Okay, but if we have enough evidence to reject this hypothesis, okay, then uh, if we reject the hypothesis, means that from the evidence, it is, it is clear, or it is enough to say that the person is actually guilty, then we will reject the H null. Okay, means that the person is guilty. So that is why in statistic it is whether we want to reject H null or whether we want to fail to reject H null. Okay, so this thing you need to remember this thing because it is either reject or fail to reject H null only. In statistics or in the hypothesis testing, we don't say things like we accept the alternative hypothesis, okay, or we reject the alternative hypothesis. We don't say things like that. It is either only to reject the null hypothesis or fail to reject the null hypothesis. Okay, I hope it is clear. It is reject or fail to reject the null hypothesis only. So when it comes to making a conclusion about anything in the hypothesis testing, you must make sure that your conclusion is based on the null hypothesis only, H null, not the H1. Okay, null hypothesis only. And the last one is an alternative hypothesis or H1. Alternative hypothesis is H1 is a claim about a population that will be true. Okay, it is only true if the null hypothesis is false. So the alternative, we can say that the alternative hypothesis is dependent to the null hypothesis. It means that if the null hypothesis is true, then the alternative hypothesis is false. If the null hypothesis is false, the alternative hypothesis is true. Okay, but in the conclusion again, still, there are only two types of a conclusion. It is whether to reject the H null or fail to reject the H null. Okay, so um, in any statistical hypothesis or hypothesis testing, there are four possible outcomes. Okay, so if H null is true and we do not reject the H null, it means that it is true, and we conclude that we or I mean we conclude that the null hypothesis is true. Okay, do not reject H null here it means that we also conclude that the H null is true. So these two are the correct decision. Okay. Sorry, this one is the correct decision. How do I think I need to highlight this. Okay. So this is the correct decision. And when the H null is false, we will reject the H null because it is false. This is also a correct decision. All right, but if we make a false conclusion, means that we reject H null, but the H null is true, then um, we are having a type 1 or alpha error. And when H null is false, but we do not reject the H null, means that we are committing a type 2 or beta error. Okay, now let's look at the next page. So there are two types of errors, as I've just mentioned earlier. We have type 1 error, okay, and type 2 error. Okay, again, the type 1 error is when we uh, we reject H null when it is true. Look here, okay, we reject H null when it is true. And the type 2 error is done when we do not reject H null when it is false. So this is the errors. Okay. Okay. All right. So now let's look at the tails of a test. Tails of a test. In this is new. Okay. This has not been discussed in the previous chapter. Okay, and I hope you can understand the types of tests or tails of a test here. So it is actually two types of tail test. The first one is the two-tail test. So okay, the two-tail test. In a two-tail test, okay, it means that we are testing our hypothesis, okay, in both tails of the distribution, on the right tail and on the left tail. So we have, if you remember, we have done this in the confidence interval in which we have calculated the confidence interval. All right. And we know that in the confidence interval, we have lower boundary and upper boundary. Okay, the same goes to the two-tail test. Okay, we are testing our hypothesis at both sides of the distribution. This is right and this is left. Okay, and one more is one more tail test is one tail test. One tail test. Okay, one tail test is divided into two. The first one is left tail test, and the other one is right tail test. Okay, so for the left tail test, we are testing our hypothesis at the left side of the distribution here. Okay, and for the right tail test is when we are testing the hypothesis on the right side of the distribution. Okay, so how to actually decide whether we have a two-tail test or we need to use the one-tail test? Okay, now it is like this. For the two-tail test and one-tail test, these two tests is actually depends on the alternative hypothesis. Okay, so it depends on the alternative hypothesis H1. H1. Okay. Now, if our alternative hypothesis is not equal to, it means that we want to test whether the CGPA of male and female students is not different. I mean, it is, it is different. Okay. So when we use the term different, for example, okay, for example, we use the term different. When the question use this term different in the question, okay, it means that in the alternative hypothesis, we will have this kind of hypothesis. For example, mean of male is not equal to the mean of female. For the alternative hypothesis, you must remember that uh, what the question mentioned will be is actually our alternative hypothesis. What the question asks us to test is actually the alternative hypothesis. Okay, so when it is not different here, when it is different, the symbol different is used here. It can be on both sides. Okay, uh, that is why we will test at the left tail and the right tail. Okay, but uh, uh, when the question asks us to test whether the mean CGPA of male is less than, okay, is less than the mean CGPA of female. So we will have an alternative hypothesis like this. Mean of male is less than mean of female. Now, For this one, we use symbol less than. Previously, we used symbol not equal to. When we use this symbol not equal to, we use to tail test. Okay, but when we use less than, we will only test the difference on the left side, less than. Okay, but if the question asks you to find whether the mean CGPA of male is greater than the mean CGPA of female, okay, now look here, we have, or we use the symbol of greater than. So when we use the symbol, the greater than symbol, then we will test the hypothesis on the right side. Okay, I hope you can differentiate these three types of hypothesis. Okay, because this is very crucial because this is the first step in the hypothesis testing. If you fail to differentiate the three types of hypothesis here, then you will have problems with the next steps of the analysis. Okay, and the other one is uh, just to be safe for the null hypothesis. Okay, just to be safe, you can always or you can use the same null hypothesis. It means that for this one, you can test or you can write down the mean of male is equal to the mean of female for the null hypothesis. The same goes to the second one. You can use the same null hypothesis. Okay. And also for the third one, you can use equal to symbol for the null hypothesis. I will use different color. Okay. When it is null hypothesis, just use this symbol. Okay. All right. You, I just want to be clear with you that you can use other symbols. For example, you can use when we are testing the mean of male is less than mean of female, you can use the symbol greater than or equal to for the null hypothesis. Okay, you can use this symbol, but I afraid that you are having problem with this or you may get confused during the assessment. So it is better to just use the equal to symbol. Okay, I hope you are clear here. Okay, and regarding the symbol of the alternative hypothesis, you may be wondering, how about how if the question asks you to find, for example, find that or test whether the mean CGPA of male is less than or equal to the mean CGPA of female, for example. So if the question mentioned less than or equal to, less than or equal to, for example, okay, you can use this symbol, less than or equal to. But usually the question just want to know whether it is greater than or less than only. Okay, greater than or less than only, because this is uh, more meaningful hypothesis or testing. We want to know whether it is greater than or less than only. We do not want to know whether less than or equal to, greater than or equal to. Okay, I hope you are clear until here. Okay, so you can go through the phrases used in the hypothesis testing, and again, all these phrases here will decide on whether to use the which type of test two-tailed test or one-tailed test. All right. Now, I think it would be better if we look at the example for you to get a more clear picture on what we are currently discussing. Okay, now let's look at example one. State the null and alternative hypothesis for each of the following statement. Okay, so we are now just want to check uh, or to write down the hypothesis, the null hypothesis and the alternative hypothesis for the situations given by the questions. Give me a second. All right. Now, uh, the first question A for in example one, test if the mean number of hours spent working per week by college students who hold jobs is different from 20 hours. Okay, so is different from 20 hours. Again, what is mentioned in the question is actually our alternative hypothesis. Remember that what is mentioned in the question is our alternative hypothesis. Because why? Uh, you can, because first of all, in the null hypothesis, for the null hypothesis, you can always use the equal to symbol, right? So when you read the question, here, case test if the mean number of hours spent working per week by college students who hold jobs is different from 20 hours. So it's different from 20 hours here is actually our alternative hypothesis. So you need to know that you must include the not equal to symbol. This is, what does this mean? This means different. This symbol means different, right? So mean spent, sorry, number of hours spent working. So you can just simply write down the alternative hypothesis as mean is not equal to 20 hours. Okay, and again for the null hypothesis, remember here you can just use the equal to symbol. Okay, so that this is for the first one. Now let's look at B. Test whether or not a bank's ATM is out of service for an average of more than 10 hours per month. More than 10 hours per month. So an average of more than 10 hours per month. So again, this is referring to our alternative hypothesis. And the phrase used is more than. So the the symbol is more than. Okay, this is more than. More than or greater than, higher than, you can always use this symbol. Okay, mean is more than 10 hours. And remember, you need to also write down the null hypothesis, and it is mean is equal to 10 hours. And that is for B. Now let's look at C. Test if the mean credit card debt of college seniors is less than RM 1000. Less than RM 1000. And for C, again, the alternative hypothesis is mean is less than RM 1000, and for the null hypothesis mean is equal to RM 1000. Okay, easy, right? Because you just need to remember that for the null hypothesis we always use equal to sign or symbol, and what is mentioned in the question is actually referring to our alternative hypothesis. And for our case right now, you should be able to differentiate that. For A, we are going to use two tail tests. For B, we are going to use right tail test. And for C, we are going to use left tail test. Okay. Now, let's look at 3.1 hypothesis test of one population mean. Okay, so based on the module that the module mentioned that there are two approaches for hypothesis test, but I have mentioned earlier that there are actually three uh, ways of test the hypothesis. Where is it? Uh, wait, yeah. Okay, but I remember that I've mentioned earlier that there are three ways of testing the hypothesis. The first one is p-value. Second one is by using the critical value approach. What I've mentioned earlier is actually statistical tests. And the third one is you can actually test the hypothesis by using the confidence interval, the one that you have learned in chapter 2 earlier. Okay, now for the p-value approach, okay, now we are focusing on the p-value approach. And I think since in the module it is only two approaches discussed, so I think we are not going to discuss the third approach because maybe this is the what is focused in your syllabus, only two only these two approach. Okay, so the p-value approach, the first one, the p-value is actually a value that can only be found in the statistical test output. Okay, statistical test output. So the first approach is actually the easier way on of how to actually reject H null or fail to reject H null to test the hypothesis, because there is no calculation required in this in your module. No calculation required. You just need to compare two values. Okay, you just need to compare two values, which are the p-value and the alpha. And how to actually reject the H null? We reject H null if p-value less than alpha. Okay, reject H null if p-value less than alpha. It is always like this. And if the p-value, if the p-value is greater than alpha, then we fail to reject H null. If p-value greater than alpha. If p-value less than alpha, reject H null. If p-value is greater than alpha, fail to reject H null. And what is alpha again? What is alpha here? What is this thing? Okay, uh, alpha is actually the significance level. The significance level of the test. If uh, the question asks you to find, for example, find or add 5% significance level, test the hypothesis at 5% significance level. Okay, so if this is the question, so therefore this is our alpha, 5%. And in the confidence interval, we have learned that if the question asks you to find 95% confidence level, okay, confidence level, yeah, confidence level. I just want you um to be able to differentiate between significance level and confidence level. If you are required to find 95% confidence level, it also means that you are constructing a confidence interval at 5% significance level, because this is alpha. And if you can recall what we have learned previously, alpha is actually 1 minus 0.95, and this is equal to 0.05. This is alpha, and alpha here is equal to this alpha. It is equal. 5% significance level is equal to the 95% confidence level. Okay, so normally in the hypothesis testing, it is not mentioned find 95% confidence level or test the hypothesis at 95% confidence level. But in the hypothesis testing, usually the question will ask you to find or to test the hypothesis at 5% significance level. These two things are the same thing. 95% confidence level is actually equal to the 5% significance level. So for this one, it is the same. Alpha is equal to 0.05. This is the alpha value. And don't worry, the alpha value or the hypothesis testing, the significance, the level of significance required to test the hypothesis will be mentioned in the question. I hope uh, you are able to differentiate between confidence level and the significance level. Okay, now for the next one is you need to find or test the hypothesis by using the statistical approach or the critical value approach. Okay, this is a bit or it is not as easy as the p-value, because first for the second step here, okay, for the second approach, you need to find the z calculated if the standard deviation or variance of the population is given or known, you have to find the Z calculated. If known, okay, the standard deviation of the population is known, and or you have to find the T calculated if the standard deviation of the population is unknown. It is the same as in chapter 2. We use Z distribution, okay, to find, for example, to find the confidence interval of one population mean, we use of the mean x bar plus minus Z alpha over 2 over this times the standard error. And for this is, I mean, this is in chapter 2. We find the confidence interval. I would like to mention that we use the Z, but if it's unknown, then we use T. Okay, plus minus T alpha over 2 times the standard error. Okay, so we use T here. If unknown, we use Z if known. Now, it is the same for this chapter. Okay, if the standard deviation of the population is known, use Z distribution. And if the standard deviation of the population is unknown, use T. But the equation is a bit different because in this chapter to calculate the Z calculated for one population mean, the formula is given by x bar minus mu over standard deviation of the population of a square root of n. This is for one population, and for T, okay, it is x bar minus mu over standard deviation of the sample of a square root of n. All right, so this is what you have to calculate first, the Z calculated or the T calculated. Next is, once you have calculated the Z score or the T score, you need to find the, how do I write this? Okay, I will just put it as this is the first step, and the second step is to find the Z critical value or the T critical value. Right. So if you calculate the Z calculated, then you have to compare the value with the Z critical value. If you calculate the T calculated, then you have to compare it with the T critical value. Okay, so for example, now I will just remove this one. Now let's say the standard deviation of the population is known. Then you calculate the Z calculated. So once you have uh, find the value, let's say the value is 2.68, for example. Okay, then you find the Z critical value. Okay, Z critical value is given, for example, given by Z 0.05, and based on the statistical table, you need to refer to the statistical table again. Find the Z probabilities table, Z distribution table. Right. This is the Z distribution table. I think it's easier to refer to the, okay, this table. So now this is our alpha 0.05, so the value is 1.6449. 1.6449. Now let's go back to this chapter, the module. Okay, and the value is 1.6449. So you need to compare these two values. Usually, okay, um, if z, the decision rule is will be like this: reject h null if z calculated is greater than z critical value. So you need to compare these two values, 2.68 and 1.6449. So what we will do is, since z calculated, what is the z calculated value? It is 2.68. And what is our z critical value? Okay, it is 1.6449. Now you need to decide whether this value is greater than this value or it is lower. In our case right now, 2.68 is greater than 1.6449. And based on the decision rule here, we will reject the hypothesis, the null hypothesis, if z calculated is greater than z critical value. So we can conclude that the null hypothesis is rejected. Or reject, you can make it simpler, just write down reject h null. Okay, because this value is greater than this value. But let's say uh, the z calculated is, give me a second, but let's say the z calculated here is 1.5. Okay, 1.500, for example. Then this value, the new z calculated, is 1.500. Therefore, again, you need to compare the two values here, 1.500 and 1.6449. Comparing these two values, we know that the z calculated is actually less than the z critical value. In this example, we fail to reject H null. We only reject H null if the value here is greater than the critical value. But if it is less than a critical value, then we fail to reject H null. And before I forget, this is for the right tail test. For the right tail test. For for the left tail test, it is different. Okay, for the left tail. Now I will show you left tail test. For the left tail test, it is usually like this: reject H null if Z calculated is less than negative Z critical value. Okay, and now here there is negative symbol for Z critical value, because why? For the left tail test, we expect to get negative value for the Z calculated. And for the right tail test, we expect to get positive value for the Z calculated. The same goes to the T calculated lah. Right? And then for this one, we will reject H now if Z calculated is less than negative Z critical value. I would like to give you a more detail by using a figure. Okay, so this is again the right tail test, right? So let's say this is the right tail test, and this is the left tail test. If the if the Z calculated here falls in this region, means that we have Z critical value of 1.6449. So if the Z calculated is more than 1.6449, it falls under the rejection region. And let's say this is 0. Okay, remember for the Z, we have 0 as the center of the distribution. And this is also the mean. All right. So the rejection region, that is why here we reject H now if the value is greater than 1.6449. But since 1.5 now, 1.5 is here. This is 1.5. 1.5 is less than 1.6449. That is why this is fail to reject region. Fail to reject region. The same goes to the left tail. So since this is 0, we know that on the right side is positive and on the left side is negative. Therefore, this is the rejection region. So that is why you need to include negative for the Z critical value. Let's say the same value or the same alpha, that is alpha Z critical value based on the table is Z 0.05, the same as is this one. So it is equal to 1.6449, right? But since this is a left tail test, you need to include negative sign, negative sign. So this is negative sign. So therefore, again, this is also negative sign, negative 1.6449. Okay, so if the Z calculated is less than negative 1.6449, if it falls under this region, this is the rejection region for the left tail test. And if it falls here, for example, the same example, negative 1.500, again, because we expect to get negative value for the Z calculated, therefore it falls under the fail to reject region. All right, so I hope it is clear, and it helps you to actually understand what it means by this decision rule here. Okay, what we have discussed is actually these two, okay, 1 and 2. And you can apply the same thing for the T calculated, the same thing, okay? It is just that if you calculate the T value instead of Z value, you need to compare the value with the T critical value. This is the T critical value. This is the Z critical value. Remember, if you calculate the Z, then you have to compare it with the Z critical value. If you calculate the T, then you have to compare it with the T critical value. And that is for the one tail test. It is either right tail or left tail. But when it comes to two tail test, so This is two-tailed test, yeah? Okay, two-tailed test. Now, let me erase all these first. Oops. All right. Oops. Now for the two-tailed test. For the two-tailed test, again, we are going to test the hypothesis at both tails. Yeah, this on the right tail as well as on the left tail. We are going to test at both tail. Okay, and if you read here, reject H null if Z calculated is greater than Z alpha over 2. Why alpha over 2? Because instead of alpha, for this one, we use alpha, 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 and alpha. But for two-tailed test, we use alpha over 2 because why? Because the alpha or the significance level need to be divided into two. That is alpha over 2 for the right and alpha over 2 for the left. Because instead of having only one, now we have two. So we have to divide them equally into two. All right. So that is why for the two-tailed test, you need to compare with Z alpha over 2 instead of Z alpha. So any value that you calculated, okay, for the two-tailed test, we expect the Z or the T calculated to be either positive or negative. We don't know. Right. So we will reject H now if Z calculated is greater than Z alpha over 2, or if Z calculated is less than negative Z alpha over 2. Okay, because why? This is not alpha, not Z alpha over 2, but negative Z alpha over 2 because it is on the left side. So if you calculate the Z calculated, oops, wait, yeah. If you calculate the Z calculated here and it is greater than Z alpha over 2 here, let's say this is the value, sorry, this is the value. So we will reject because it falls under the rejection region. The same goes to this one. If the Z calculated is here is here less than negative Z alpha over 2, then we will also reject the null hypothesis. Right. So I think for this one, it is better or it will be better if we discuss it by using the example. It will be you can see it clearly. Okay, and I will skip the steps here. I will skip the steps here because as well as for this first step here, because I will show it in the example. Now, let's look at example 2. A telephone company provides long-distance telephone service in an area. According to the company's records, the average length of all long-distance calls placed through this company in 2009 was 12.5 minutes. So this is the what? This is the average, right? Oops, sorry. I don't know. Now highlight the information. The average length of all long distance call was 12.44 minutes. This is based on the company's record. Okay, based on the company's record. So this is what? This is actually our mean. 12 point mean of the population because based on the company's all of the company record. Okay, so 12.44 minutes. And next, the company's management wanted to check if the mean length of the current long distance calls is different. Now, this is the second point. Is different from 12.44 minutes. Okay, so this is actually our alternative hypothesis. Therefore, for step one is the hypothesis. You need to write down the hypothesis, and from the question, the alternative hypothesis given is different from 12.44 minutes. So mean is not equal to 12.44. Oops. Mean is not equal to 12.44. And from here, we also know that our null hypothesis is mean is equal to 12.44 minutes. Okay. And for the null hypothesis, remember, always use the equal to symbol just to be safe. And from here, a sample of 150 such calls placed through this company produce a mean length of 13.71 minutes. So we have a sample calls of 150. So our n is equal to 150, and from the 150 such calls we get a mean of this is S bar, the mean of the sample, and this is the mean of the population. Based on the sample, the mean is equal to 13.71 minutes. Right. And the standard deviation of all such calls, this is also the information that you need to be aware of to decide whether to use Z or T. So the standard deviation of all such calls. It means that this is the standard deviation of the population. This is not the standard deviation of the sample, right? Therefore, we use the sigma sign instead of S. We use sigma because sigma is the standard deviation of the population. So the standard deviation of the population is 2.65 minutes. Okay, this is very important because why? Because from this information, we are able to decide that we need to use the Z, or we need to calculate the Z instead of T, because the standard deviation given is the standard deviation of the population. And using 2% significance level, can you conclude that the mean length of all of all current long distance calls is different from 12.44 minutes? Okay, so you need, okay, sorry, you need to read the question word by word, and you need to write down all information given. By only doing this, you are able to know or to decide which technique to be used, whether to use the Z, distribution or the t distribution in your calculation, what is the alternative hypothesis, what is the significance level, and so on, right? So now, this is step one, the hypothesis. And for step two is you can actually calculate. But for me, step two is better for you to write down the significance level. Okay. And our significance level is this one, 2% significance level. So our alpha is equal to 0.02. Our alpha is equal to 0.02. And um, since we are using two-tailed test, why two-tailed test? Because uh, we want to know whether it is different or equal. So when alternative hypothesis use this symbol, so we need to use the two-tailed test, not one-tailed test. Kalau one-tailed test macam mana? Kalau one-tailed test, again, if you use greater than symbol, this one is one-tailed test. Or if you use less than symbol, this is one-tailed test. But now we want to check whether it is different or not. Different or not is like this. This is two-tailed test. And as discussed earlier, when it comes to two-tailed test, we need to use alpha over 2. In our case right now, we use alpha z, alpha over 2 lah. But okay, significance level is alpha over 2, right? Like this first. So 0.02 over 2 is equal to 0.01. That is step 2. Now, step 3. Step 3 is the statistical test. Statistical test. So all the sorry, I think we use the test statistics term. Test statistics. Okay, since the standard deviation of the population is given, we know that we need to use the Z calculator. So use Z. Z calculated is equal to X bar minus mu over standard deviation of the population over square root of n. This is equal to, what is our S bar? S bar is 13.71 minus 12.44 over standard deviation of the population, that is equal to 2.65 over 1 over square root of 150. So calculating this, you will get the Z calculated, that is equal to 5.870. So this is our Z calculated. Now, since you have calculated the Z calculated, then the next step is step 4 is to find the critical value. And to find the critical value, now you have to remember that now we are doing a two-tailed test, and that is why we need to calculate or find the Z critical value based on the alpha over 2. So now your Z critical value, that is equal to Z 0.01, and by referring to the statistical table, the Z 0.01 is equal to 2.3263. So let's go back 2 point. This one is 2.3263. Okay. And the next one is now you already calculated the Z critical value, and we have find the Z critical value. Sorry, Z calculated and Z critical value. And now what you need to do next is to compare these two values. So we need to use the decision rule. So from here, you need to refer to the table up here in which, all right, so this is our table, right? Wait here. So where is our table? I think it's up here. Okay. Now look at this table. We are doing a test where for the case when the standard deviation of variance of the population is known. So cancel all of this, and we are currently doing this one, a two-tailed test, right? So this is the decision rule that we need to use for our study right now. And go back here. So our decision rule is reject H now if Z calculated is greater than Z critical uh, value. This is for the right tail, or if our Z calculated is less than negative Z critical value. Okay, this is for the left tail. Remember, we are testing at both tails of the distribution. So that is why for the left tail, we expect to get negative value for the Z calculated, and that is why we need to add up negative symbol for the Z critical value. But now, since we have a positive value for the Z calculated, we just need to compare with the positive value for the Z critical value. So we are using this, the first one lah. So now for the decision, since or you can just simply write down that calculated is equal to 5.870, um, and Z critical value is equal to 2.3263. Okay, now let's say in our case right now, Z calculated 5.870 is greater than uh, Z critical value, which is equal to 2.3263, right? So in step 6, the decision, because of that, because this comply to this, therefore our decision is to reject H null. Reject H null. But in case, for example, you get a value like, for example, instead of 5, you get 1.870, and from therefore from here, you will compare 1.870 with Z critical value. In this case, you with the Z calculated is less than the Z critical value, right? So when the Z calculated is less than Z critical value, remember positive need to be compared with the positive, and when it is less, here you will need to write down fail to reject H now, because it does not comply with the Z with the decision rule. But for our example right now, we have 5.87. So therefore, here is also 5.87, and this is greater than. So since it is greater than, it is comply with the decision rule. So in our case right now, the decision is to reject H now. And since we reject H now look here. Oops, oops. Now we reject H null, right? So when we reject H null, it means that we can conclude that the mean is different from 12.44. So for the decision, sorry, for the conclusion, Step 7, the conclusion. We can conclude at 2% significant level that the mean mean of what is it again? This one, the mean length of all current long distance call is different from 12.44. That the mean of wait, the mean length of all current, the mean length of all such calls is here. Such call is different from 12.44 minutes. All right. So again, as I've mentioned earlier, if let's say, oh, sorry, I think uh, it is better to write the conclusion like this. At 2% significance level, it is sufficient to conclude that the mean of all such calls in different is different from 12.44 minutes. But and the reason why I rephrase the wording is because for example, let's say from the decision here, you get something like fail to reject H null, fail to reject H null. So for this one, what you need to do in the conclusion is just you include then we say that it is sufficient evidence lah to conclude that it is different. So it is easy for you to, I mean, it's like that we have a template of writing a conclusion because just change here sufficient, whether it is sufficient or insufficient. Remember, if reject H now, then we use sufficient. If fail to reject H now, then we use insufficient. And for the conclusion, for the later part of the conclusion, the mean of all such calls is different from 12.4 minutes. This one you can get it from the question. This one, okay? This one. I will highlight it with maybe yet green color, okay? It is from the question. Different from 12.44 minutes because remember again anything that we conclude is based on the alternative hypothesis and the alternative hypothesis is we get it from the question. All right, and yeah, this is for the two tail test. And later, maybe next week, sorry, in our next class, we are going to discuss example number 3 here. Okay, for this one, we are going to do an example for one tail test. But I think that one is okay. We are going to cover it in our next class because, yeah, because there are a few more examples that need to be discussed, and I'm just afraid that it is too much for you to grab everything in one class. So yeah, I think that's all. If you have any question, please send me a WhatsApp message via our WhatsApp group. Okay, so just text me if you find it difficult to understand any part of the class today. All right, I think that's all. Thank you very much and see you again in our next class.